Hello everyone. Today in this video I will demonstrate one of my project which is based on ROS. In this project I will control a TurtleBot in the Gazebo environment. Before diving into this project, let me briefly explain what ROS is. ROS stands for Robot Operating System. ROS is basically a framework where a robot can be programmed so that we can control the robot like the way we want. A robot can be programmed in so many other ways, but ROS provides a collection of tools and libraries that helps the developer to control a robot more effectively and efficiently. ROS operates using node-based architecture. Nodes are basically the different processes which can communicate with each other by passing messages. So all we need is two nodes, one subscriber and one publisher. The publisher sends the message and subscriber receives it. That's it. Okay, now let's see the nodes inside the workspace. Okay, so this is my publishers node and here are my subscriber node. I have written two subscriber node because as by the name, one is written with the implementation of PID and another is written without the implementation of PID. So first, the node is initialized by the name viewController, and then this node sends the message to the topic named target coordinate. Then this is the just the give using the tkinter written in Python, and finally the inputs are taken by the x and y value and simply publishes it to the topic. Okay, so this is my subscriber node with the implementation of PID. Here we can see that there are two classes, one for the PID controller and another for the main function of the robot. So in PID class, what a PID does is it simply controls the velocity of the robot. That is, when the robot is far away from the goal position, it sets the velocity of the robot to high, and when the robot is closer to the goal position, it sets the velocity of the robot to low. That is, the velocity of the robot decreases as it approaches toward the goal position, so that the robot does not overshoot the goal position. And in the main function, we can see that we have used two PID controller. That is, one for the linear velocity and another for the angular velocity. And here some data are stored in the CSV file so that the results can be compared graphically. Here we can see that the robot reached its goal in two phases. In phase 1, the robot simply rotates in the direction of the goal position, and in phase 2, the robot simply goes to the goal position. And that's pretty much it for the PID implementation subscriber node. And let's see the subscriber node without PID implementation. It's basically the same thing, just one difference that we have not used the PID. Instead, we have set the velocity at a constant rate, and otherwise it's the same code. Okay, now let's run the code and see how the TurtleBot moves in the Gazebo world. Okay, so after running the TurtleBot, I have received these CSV files. Um, so now I will just basically compare the trajectory data, that is the path taken by the robot, with PID controller and without the PID controller. So let's see the graphical representations. So we can see that these are my two results, and this is the graphical representation with PID controller, and this is without the PID controller. We can clearly see that with PID controller the path is much smooth, and the goal position is very much accurate. And on the other hand, without the PID controller, the path is not smooth, first of all, and the goal position is also not accurate. That is, the robot overshoots a little bit. So these are the basic difference between the PID controller and without the PID controller. So that's it for my project. Hope you like it. Thank you.